Okay, everybody, so what I want to do here is I want to analyze the math behind those die rolls we just looked at. Now, there's a little bit of math you already understand. When you throw a die, there's a 10% chance of getting a boy and a 90% chance of getting a girl. That's pretty straightforward. It's like flipping a coin with weighted probabilities. I often ask the question, what's the chance I get hit when I ride home from work on my bike? And people say, well, you either do or you don't. And I say, so is it 50-50? And then they scratch their heads because they're like, it can't be 50-50. It's got to be more one than the other. And that's what I want to use today to analyze. What's cool about what we'll look at here over the next couple videos is it'll generalize to 50-50, as we'll see in class on Tuesday. But it generalizes beautifully for this idea here in class right now, or in video class right now. So what I want to do is I want to build the flock one at a time. Because when Max goes into the store to grab one of these birds, there's just 1,000 birds in the store. And he goes in and he grabs one, or he looks at one he wants and he says, I want that one, and we help him grab it. Well, he's big now, he grabs it himself. But the thing about it is that when he grabs that bird, is a 90% chance that particular bird is female. So when he drops that bird into the box to bring it home, we look at it and go, okay, well, I hope that's a girl. So what we're interested in is the number of girls in the box. So what I want to do first is I want to do flock number one. And flock number one is I just buy one bird. The first one that Max grabs and drops into the box. And I'm interested in the number of girls that I get. Now if you think about it, if I buy one bird, the number of girls is pretty straightforward. I either get one or I don't. So I either have no girls or I have one girl. That's it. Either 0 girls or 1 girl. Okay? So the idea is, what are the chances of these things happening? What are the chances of these things happening? Well, the chance that I don't have a girl means I have a boy. And since Joel told me the chance of a girl is 90%, that means the chance of a boy is 10% in this case. Okay? So fairly straightforward. Fairly straightforward. Notice how it meets all the requirements for these distributions we've been talking about. You've got all the random variable possibilities here in the left column. You've got all the probabilities here in the right column. And notice they also sum to 100%, which is good. We need that. That has to be true, or it's a bad, or it's a broken distribution, so to speak. So this is the simplest distribution we can have, and it's fine, but it's not interesting, because that's like taking the one die and rolling it. We rolled the die a number of times, and that's what I want to look at with you all today. Is I want to look at what happens when Max starts adding birds. So let's put a little line here, and let's look at flock 2. So this means that we've got 2 little fuzzy birds in the box now, 2 fuzzy birds. So what I want to do is I want to make one of these for this situation. And that's what's cool about a distribution. If the situation changes, you just change the distribution to match it, which is so interesting. These are so useful in so many ways. I mentioned in class the ways you can use them for things like insurance. My family uses them constantly to decide if we should do something or not. It's a wonderful, even if you use them informally, it's a wonderful strategy for wise choices. So let's do the same thing. X equals number of girls, and the probability of X column. So the first thing you have to ask yourself is, okay, now I'm looking at a box. It's got 2 chicks in it. Box, 2 chicks. How many girls could I have in the box? Well, there might not be any. Or there might be 1. Or there might be 2. That's the possibility, right? So then you might be looking over here at this side and going, okay, so how is this like this? Well, I can tell you how it's like this. This still has to sum to 100. This is correct, because if you have 2 birds in a box, this is the number of girls you could have. The challenge is here. How do you do this? And this is where you have to think back to your last couple projects, especially the previous one from this, which is when we did compound probabilities, where we were multiplying them as we did them sequentially by that fundamental counting principle. So let's look at this. The number of girls. What's the chance of not getting any girls? Well, if he's not getting any girls when he grabs 2 chicks, that means he got 2 what? Exactly. Boys. I hope you said boys. If you don't, think about it. He grabs a bird. It's either a boy or it's a girl. If he doesn't get any girls, That means they both have to be boys. They both have to be boys, okay? They both. So that means there's a 10% chance he got a boy first and a 10% chance he got a boy second. Now think about what I just said. There's a 10% chance he got a boy first and a 10% chance he got a boy second. And if that's true, and means multiply, so that means the chance of getting 2 boys is going to be 1 in 100. 1 in 100, okay? That's extraordinarily small. But it should be small. It's hard to get 1 boy, let alone 2 of them. It's hard to get 1 boy, let alone 2 of them. Fair enough, hopefully, maybe, hopefully. Looking at this, it's a little bit cluttered up there, so I'm going to rewrite this as 0.1 squared, which is 1 in 100. I'm not doing the best board management right now. I'm gotten used to the library and having all that space. So I'm going to call that 0.1 squared and call that 0.01. Very unlikely. It means, let's look at what it means again. If I send Max into the store to buy 2 birds 100 times, expect in 1 of those 100 times to get 2 boys. You think of it that way. That's a pretty good way of actually thinking about it. Can you think of the other case which is like parallel to it, similar in mathematics? Exactly. This one. Because if you get 2 girls, that means it's going to be 0.9 squared, which is 0.81. 81%. 81%. So this is 81%. That means this, the option of getting 2 girls is going to happen 81% of the time. 81% of the time. Now think about that. This is the most likely outcome, but it's less than getting 1 girl. Why would it be less than getting 1 girl? Because you're rolling a die. Every single time my son goes in and grabs one of those birds, assuming he's doing it randomly and assuming the 90% is correct, the chance goes down that they're sequentially birds every time, every time, every time. Hold on that thought, we're coming back to that. So now that you've got 2 of these things, you now know what the third one has to be. If this is 0.81 and this is 0.01, together that's 0.82. That's an 82% chance of one of those 2 things happening. If that's 82% of the time, that means this, whatever's here, has to be the remainder, which is what, 82. That's going to have to be 18%, right? There are your probabilities right there. There's a 1% chance you're not going to get any girls. There's a 81% chance you're going to get both girls, and there's an 18% chance you're going to get 1 of each. If some of you are thinking right now, wait a minute, I'm trying to mathematically, like this, figure out this one, and I'm hanging up because the numbers aren't working. Hold that thought. We'll come back to that. We'll come back to that in the 3 flock case we'll do here in a second. But you're correct. There is one little thing that might be throwing your math off in your mind, but we'll control for that in a second, I promise. So, one bird, 2 birds, we'll move on to 3, and then 4 in the next couple of videos.